Okay, so now today we are going to start with a very interesting problem statement. Okay, so what's the agenda for today's session? The agenda for today's session is try to solve kind of like a low level design, kind of like an interview problem for whom this kind of a problem is actually relevant. If let's say you are, let's say, interviewing for a backend engineering role, or let's say you are interviewing for a software engineering role, a lot of times a few startups and a few companies might want to actually judge you on your, I would say, object oriented programming skills. They want to technically judge you that how clean of a code you can actually write, and if you are able to technically solve a real life problem altogether, right? A good mix of both of this is kind of like an LLD interview or a machine coding interview. In a machine coding interview, what happens is that you might be expected to technically solve any particular problem. You might be expected to create an application. That application can be anything: a hospital management app, maybe kind of like an elevator design, an ATM machine, and whatnot. Okay. And in this machine coding problem, you're expected to write proper class based solutions that can actually work in a production level system. You need to make sure that the solution is as clean as possible. Okay. And that's what the agenda for this particular session is as well. In this particular session, we are going to try to design an ATM machine. It's a very famous problem. A lot of times in a lot of low level design interview, you might be expected to design an ATM machine altogether. So we are going to start from the very scratch. Let's say if an interviewer is sitting in front of you, and let's say the interview starts, and they're going to ask you the question that, hey, so the problem for today is that we need to design an ATM machine. Okay, you do not need to design, let's say, the API part or maybe the database implementation altogether. But what we focus on, we are focusing on the service layer. We are focusing on the service layer. That is the business logic part, that how exactly you are going to arrange the service layer, how you are going to arrange the business logic part, so on and so forth. Okay, that's going to be the agenda. That's going to be the agenda. So now how should we technically approach the problem? Let's start talking about it. If let's say somebody gives you an ATM machine kind of a thing, first of all, you should clarify the, I would say, expectation. What is the expectation from the ATM machine altogether? Okay, so the good set of expectation, a good set of expectations can be that, let's say, user will be able to dispense some cash out of the machine, right? This can be a good expectation to have, that our users are able to kind of like dispense some cash altogether, right? Users can insert a card, put some details, and if the details are valid, then cash will be given. Cash will be given, something like this, right? And maybe, let's say, because we are designing ATM machine, we don't want to be in a situation that, let's say, we just design one single ATM machine. Generally, banks have multiple ATM machines altogether. So consider that a bank might be having a lot of ATM machines, a lot of ATM machines. So the solution must be generic for all. The solution must be generic for all, right? That is also one expectation that we should have. We don't need to implement any DB or APIs whatsoever. Okay, we don't need to implement any kind of a DB, or we don't need to implement any kind of APIs. We are just gonna focus on the service layer. This is technically the expectation out of the problem, right? I believe the expectation is making sense to everyone. Just quickly drop a yes or no in the chat. Okay. Celtics PD, I believe you should try to give some mock interviews, try to arrange some mock interviews with your maybe teammates, and try to start giving some interviews in some product based companies. This will help you to take a quicker shift. Focus a bit on DSA as well. But first of all, is this point making sense to everyone? Is the problem statement clear to everyone, that what do we want to design? So these kind of expectation, that what we are expected to design, you can actually take this expectation from your interviewer, that what we are actually expected to design. Now, a lot of times these kind of machine coding problems are open-ended, right? So it's up to you that you design a solution that is doable in probably 45 minutes or 50 minutes. Why? Because generally the last 5 minutes are kept for some questions, and the initial 5 minutes you are going to keep for understanding the problem statement. So more or less you are going to have more like 45 to 50 minutes, including the part that you have to code it as well. So you need to make sure that whatever design you are going to propose, you need to make sure that whatever design you are going to propose, that design should be like explainable and codable in 45 odd minutes. Okay, so that is also something that you have to keep in mind. Okay, let's start talking about the solution. Let's start talking about the solution, that how can we make a ATM machine. Now we can think about a brute force solution. Like if let's say you don't know anything, like, and you just want to start with a raw implementation. Let's say approach one. What can be the first approach? The first approach will be that, okay, there will be an ATM machine. Every ATM machine will be having some kind of a logic. So how about we implement one ATM class which has a couple of functions, to be performed on the ATM machine. How cool is that? That let's say you have an ATM class. Inside that ATM class, you are going to have, let's say, a couple of functions that will help you to, that will be technically implemented on the ATM machine. Also, one more thing, in a lot of machine coding interviews, the first and the foremost priority is the class, I would say, orientations. Even if you write some very basic logic in the functions, that should be more or less a good to go. Okay, so I'm going to write kind of like a pseudo code, maybe something like in maybe JavaScript or TypeScript, like anything we can technically pick, right? The implementations are going to be more or less similar in any kind of a object-oriented programming language. Okay, so let's say we are going to pick TypeScript. So we're going to say, let's say class ATM. Okay, very simple and basic class ATM we are going to pick. Okay, now let's say there are a couple of functions: public, validate, pin, right? This is, let's say, one function that on your ATM machine you are able to validate the pin altogether, right? Okay, then let's say one more function can be public deposit, okay, or deposit, okay, and so on. Like different kind of functions are there. But now it's up to you. You have to decide that what all functionalities you want to technically support, right? You want to decide what all functionalities you want to technically support. So instead of supporting every possible thing on an ATM, we are going to just focus on one flow. You can tell this to your interviewer that we are going to just focus on one flow, that is the cash withdrawal flow. We don't want to focus on deposit and everything. We just are going to focus on the cash withdrawal flow. So how the cash withdrawal flow should look like? There should be technically a insert card method, which will actually process the insertion of a card. Then there should be a, let's say, a enter pin method, which will technically help you to enter the pin altogether, right? Then there should be, let's say, a function request cash altogether. Okay, there can be a function to cancel transaction. Okay, then there can be a function to withdraw, or I would say dispense cash, right? And maybe there is a function to eject card, and so on. There are a lot of functions that you can implement, and each of these functions are going to have some kind of a functionality. Okay, again, we are just going to focus on one flow, that is the cash withdrawal flow. So I'll write it here as well. We will be focusing first on cash withdrawal flow, because you don't have enough time. Like in 45 minutes, you cannot design every single flow of the ATM machine. So you need to make sure that you are focusing on one simple thing. Okay, and let's say this is your class ATM. But if let's say you prepare a class like this, do you see any problem? Anybody of you, do you guys think there is any problem with this particular class? Anybody? Yes, this class on a 100 level violates so many solid principles. The first solid principle that this class violates is the single responsibility principle. This ATM class has a lot of responsibilities. This ATM class is also responsible for entering the pin. This ATM class is also responsible for dispensing the cash. This ATM class is also responsible for ejecting the card and whatnot, right? So single responsibility principle is technically being violated here. That is the first part. Okay, the methods are public methods, and we are good with that because anybody can call these methods. I have not written any properties yet, so we can keep the properties private, but we don't have a proper set of properties yet because we just started with a boilerplate class. And this can happen with you. Like the moment you get the question, the first instinct might come up to you that, okay, let's implement an ATM class and have all of the functions. Generally you write DSA codes like this, but that's not how you write production code, because this is going to violate, first of all, single responsibility principle. Second, the second principle that it is going to violate is open close principle, that our class should be open for extension but closed for modification. Now just think about it. If there is any new flow that you want to add in your ATM, let's say you want to add a flow of depositing the cash, then you can see again a lot of changes will happen in the ATM class. So open close principle is also being violated. Can I say that? Okay. So you can see a couple of solid principles being violated, and this is definitely not the pretty much the right way in order to implement this particular solution, right? Definitely not the right way to implement this particular solution. So anybody who can think of any good solution that we can have? Anybody who can think of any good solution that we can have? Because we have a few solid principles being violated here. So anything that you can think of. Okay, let's start talking about it. Now, the most important thing that you should see here is that whenever you start any flow, okay, whenever we start any flow, say withdraw cash, our ATM machine, our ATM machine goes through a lot of state, Okay, why a lot of state? When you start withdrawing the cash, what's the first step of cash withdrawal? The first step of cash withdrawal is technically inserting the card. Then second state is entering the pin, or let's say doing the reading of the card details. Then if the card details are good to go, then you dispense the cash and then you eject the card and so on. So you can see throughout this, I would say, process, our ATM machine goes to a lot of phases. Can I say that? So for example, initially, probably our ATM machine is in a ready state. Our ATM machine is in a ready state. Okay. Now, when we initialize the transaction, right? Let's say we initialize the transaction. The moment you initialize the transaction, then what will happen is the user will insert the card and our ATM machine will be in a card reading state. Okay, this is the card reading state that you have to read the details of the card. Okay, you have to read the details of the card. Okay, now once you start reading the details of the card, let's say once you read the card, right? Once you have completely read the card, then what is going to happen? Then you are going to see some response. Let's say response of card reading, something like this. Okay. Now, this response of card reading, now based on this response of the card reading, whether this response is a valid response or an invalid response, multiple things can happen. Just think about it. Consider that this is a valid response. Consider that this was a valid response. Valid. If it is a valid response, then technically we should go to the withdraw details, right? Withdraw details reading. Okay, what's withdraw details reading? Withdraw details reading means that how much amount of cash do you want to withdraw? Because generally the ATM machine first of all checks your card and then they try to actually get the details of how much cash you want to technically take out. Okay, cool. Now once you have the response of withdraw details, once you have, let's say, the response of withdraw details, right? Then if this is a valid response, let's say you have given a valid amount of money to withdraw. Let's say the ATM can only process 20,000 rupees at one time, but you are putting 1 lakh rupees. In that case, it's an invalid response, right? But if you put, let's say, 10,000, that's a valid response, right? So there can be a valid or an invalid response in this case. So consider that, let's say, this is a valid response. Consider that this is a valid response. If it is a valid response, then our ATM machine will go in a cash dispensing state. Okay, and then once the cash dispense is completed, cash dispense, then where do we go? We are going to go inside a card ejection state, eject card state. eject card state. Okay, so once this is done, then we are going to go to a eject card state altogether. Okay, you can see our overall system goes through a lot of states. These circles are technically the states our ATM machine is going to go through, and these squares are the response that might come from a particular state. Now just think about it. There can be more situations here, right? For example, when you are reading the withdraw details and it's an invalid amount, let's say the ATM can only process 1 lakh rupees, but you gave 20,000 rupees, but you gave 1 lakh amount to withdraw. That's an invalid response, right? In case of an invalid response, it is going to eject your card. Apart from this, when you are reading the card details and the card details are invalid, then also it is going to eject your card altogether. Can I say that? Or maybe when we are putting the withdraw details, somebody press the cancel button. There is a cancel button also in the ATM. Somebody press the cancel button. If somebody press the cancel button, then also we are going to go to the card eject state, right? If somebody pressed a cancel button on withdraw details, or maybe somebody pressed a cancel button on card reading state. Okay, so let me put it like this. Somebody pressed a cancel button on card reading state, then also it will go to eject card, and so on. You can see there are a lot of situations that can technically come up based on what is the current state of the machine, or I would say ATM machine, and what operation you are performing. Based on that, things can actually go in a different direction. For example, let's say we are in a card reading state and we cancelled the transaction. If you cancelled the transaction in the card reading state, you will go back to the ready state. If let's say you cancelled the transaction in a card reading state, you will go back to the init state altogether. Okay, and so on. And once card ejection is completed, let's just think about it. Once card ejection is complete, then we are going to go back in the ready state. Okay, once card is ejected, if the card is ejected, then we are back in the ready state that we can actually perform one more operation, and that's it. You can see different I would say positions. In those positions, different responses can come up, and different actions can be taken by the user. Like when the card is being read, instead of putting your card details, you press the cancel button, then you are going to eject the card, and so on. So this is what is going to be a typical flow of an ATM machine, and you will be expected to think about this kind of a flow. Right? That our ATM machine is not just a simple class which is just having some functions. Technically, our ATM machine is a state machine. That means for everything that is being done in the ATM machine, it goes through multiple states. At each state, you can perform some operations, and maybe you won't be able to perform some operations, right? So based on what you are able to do in a particular state, you might have to technically make a workaround altogether. How many of you guys are able to get this point? Say a yes or no in the chat. You'll get the mail soon. If it's been 24 hours and you have not yet received it, I'll check, but within 24 hours you should receive the mail altogether. Guys, how many of you are able to get the point that the ATM machine that we are talking about is kind of like a state machine, that it has multiple states? Whenever something is going to happen, it moves from one state to another state, kind of like that. Okay, is this point making sense? Say yes or no in the chat. Okay, if our ATM machine is kind of like a state machine only, then let's talk about it. So if let's say I have an ATM class, do you think we should keep properties like private, and let's maybe call it as insert card state property, then private eject card state property, then let's say private enter pin state property, and so on? Do you think these different properties we should keep? No. Why? If we will keep individual properties as classes, can you see all of these are states? Instead of managing individual states, we should technically have a interface that is a state interface. Otherwise, this will violate the dependency inversion principle. This will violate the dependency inversion principle altogether, right? So ideally, what should happen is we should technically get some kind of like an ATM state. We should technically get something like an ATM state. Okay, that ATM state can be a interface that we can technically keep. Okay, so let's start with that instead. Instead of an ATM class, let's prepare an interface in TypeScript. This is a TypeScript code, but you can write similar code in Java as well, or C++ as well. In C++, you don't have interfaces, you have abstract classes. So interface ATM state. Inside the ATM state, what all possible states an ATM can have? You can have a, let's say, insert card, right? Insert card, which will be a void method. Then you can have eject card, which will be again a void method. Then let's say you have enter pin, which will be again a void method. Then let's say you have request cache, which will be again a void method. And you can see different states. Like I'm thinking about new states. You can keep only these states as it is, or maybe you can yourself think about more states that you can segregate your flow into. Cancel transaction. Okay, this can be there. And a few more properties I would like to keep in an ATM state. One property can be get state name, which will be technically a string that will tell the position of like which state we are at. And there will be an enter state method, which will be a void method. Okay, this method will help us to enter a given state. Okay, so now think about it. This ATM state interface is going to be implemented by multiple class. So for example, one class can be a ready state class. One class can be a ready state class. If you are in a ready state, then maybe we can insert the card. That's good, right? But if you are in a ready state, can we eject the card? No, you cannot eject the card because there is no card inserted. There is no card inserted, right? So if you are in a ready state, you can maybe insert a card. That can be an action. So think about it like this. So at any point of time, if let's say you have a state, S, and you have another state, let's say S2, let's keep it S1. Okay, so S1 and S2 are states, and to move from one state to another, there will be some action, right? You have a state S1, you will do some action to move to state S2. For example, if you are in a ready state and we insert the card, then we will move to the card reading state. But if you are in a ready state, we cannot eject the card. So if somebody tries to call the operation eject card, we can throw an exception that, hey, you are in a ready state, you don't need to technically eject a card, right? When you are in a ready state, you do not need to enter any pin, right? So this kind of an implementation we can technically get. Okay, that every state is going to tell, based on these action, what will be the next state they can go to. These methods are nothing. These methods inside the ATM state interface are nothing but the actions based on which one state is going to go to another state. Are you guys able to get this point? So technically, S1 is going to be type of ATM state. It is going to be of type of ATM state, right? And S2 is also going to be of type of ATM state. Okay, ATM state altogether, right? And then there are some actions. What are these actions? Actions are like insert card, eject card, enter pin, and so on. These are some of the actions that will be performed so that one state can move to another state. How many of you guys are able to get this point? Say yes or no in the chat. आदित्य वेब डेवलपर भी बैकएंड लिखता है ना? नहीं लिखता? Web developer also writes backend, so you might have to implement these kind of logics. Okay, make sense? So these are the actions. These are an action. Okay, cool. Now, don't you think that now we have a ATM state interface? We have an ATM state interface. Now, at any point of time, when you're going to start a transaction, that's where your ATM comes into the picture. to start a transaction, we will use an object of ATM class. ATM class. So you are going to use an object of the ATM class. Okay. So how the ATM class now looks like? What do you think? How the ATM class will look like? Okay. Every ATM will be having a state, which is of type ATM state. Can I say that? Every ATM will be in a state. Either it will be in a cash withdrawal state, or it will be in a ready state, or it will be in a eject card state or ejecting card state, and so on. So every ATM will be in some kind of a state. Yes or no, guys? Yes or no, everyone? Is this one making sense? Just think about it. A bank has 10 ATMs. Every ATM, like some ATMs are in a ready state, somebody is already doing the transaction in the ATM. So those ATMs are in maybe, let's say, cash withdrawal state. Somebody has completed the card, like the or maybe canceled their transaction. So those ATMs are in cash withdrawal, eject card state, and so on. So there can be many states that you can be in, right? There can be many states that you can be in, right? So a few ATM states can be ready state, then you have cash withdrawal state, then you can have ejecting card state, and so on. There can be different type of states. So every ATM will be having a state property. Make sense? Okay. Now every ATM should be having a unique identifier also. Ideally, every ATM should be having a unique identifier. So we can keep a private ID. Let's maybe keep an ID of type string. Okay, that's an ATM ID. That's an ATM ID, which is a unique identifier. Which is a unique identifier. Are you guys able to get this point? Okay. And because ATM is a service layer communicates to what? Service layer communicates to your repository layer or the DB access layer. Can I say that? So technically, I'm just writing a hypothetical implementation, but technically there should be a private DB repo, which will be of type I would say database repository. Can I say that? This will be used for DB queries. Okay, although you do not need to implement a DB at all, but you can at least simulate a DB connection. You can simulate a DB connection. How can we simulate a DB connection? Let me show you. So let's say you have a DB repository class or database repository class. If you know about repository pattern already, repository pattern helps us to make sure that our service layer is segregated from the data access layer or the data query layer. That is the repository layer. You do not want to tightly couple your database queries inside your service layer, because the same business logic that you have written in the service layer might be used on a MySQL DB, or at the same later, let's say you want to migrate from MySQL to something like Google Spanner. So the same logic can be implemented with Google Spanner only, just the DB queries will change. So database repository or the repository layer will help us to put a proper segregation in between, right? Now, let's try to write a hypothetical database repository. It's a hypothetical one. Okay, ideally, it should have some kind of a DB connection logic, and it should be able to query the DB. But maybe we can have something like private ATM data. Okay, I'll just hard code the data maybe somehow. Okay, it should be of type and of a type object. Okay, and then it will be having a ATM ID, or let's just say ID of type string. This is going to be the key. And the value should be balance. Let's say some number will be the balance. Correct pin. Okay, correct pin of type number. Okay, and status of type string. Something like this, like some kind of a database entry will be there, right? And what we can do is we can hard code this. We can technically hard code this. Okay, so let's say one user account ID is, let's say, 001, and it is having balance of 500 and correct pin, for example. Although you should not store the pin directly, but again, as I mentioned, we are just mimicking the I would say DB layer altogether. 1 2 3 4, and status is init. Why we are keeping this DB layer? Because technically what will happen is every ATM that you have, whenever any change happens to that ATM will be technically making a network call. It will be making a network request to our bank servers, right? To our bank servers. So that on the server side, we can keep an idea, right? On the server side, we can keep an idea of what actually happened with the last transaction of a user. Nitin says, why we are doing it in TypeScript? My question is, why we cannot do it in TypeScript? Like, what's the problem? You have classes, you have interfaces, you have everything to do. So you can do it in Java as well. No problem. Make sense, guys? So there will be some kind of an network interaction to the bank servers, and these bank servers will be technically maintaining the databases. So, but here we are just mimicking the DB layer altogether. Make sense, everyone? Yeah, of course. PIN should be technically encrypted, but again, we're just putting a hypothetical situation there. So we have some kind of an ATM data, and then let's say we have some fetch ATM details function. Okay, so let's say we have a fetch ATM details function, which takes an ATM ID of type string and gives us some ATM details, right? Then we have, let's say, some update ATM balance function, right? That again takes a ATM ID of type string and a new balance of type number. Okay, I'm not implementing these DB calls, but you can assume there will be some kind of a DB call here. Update ATM status will be ATM ID of type string and new status of type string. Okay, so these kind of a DB repository functions will be there. And now, whenever we are going to instantiate a brand new ATM, then technically we'll be having a constructor. We'll be having a constructor of the ATM, right? Now, whenever a new transaction is going to start, we are going to tell which ATM's transaction we are going to start. So we are going to give an ATM ID of type string, and let's say DB of type database repository. Simple, I would say, constructor injection we are going to do, and we'll say this dot ID is equals to ATM ID, and this dot DB repo is equals to DB. Okay, simple constructor injection so that we have the ATM ID and the DB associated. Now, once you have the database associated and you know what ATM ID you have, then you can fetch the ATM status. Right? So we can say const details is equals to this dot DB repo dot fetch ATM details, and you can pass the ATM ID. So this is going to give you the ATM details, right? Now, based on the ATM details, you are going to initialize the ATM state. That maybe your ATM was in a init state or a ready state, or your ATM was in a transactional state, and so on. Some kind of a state you are going to initialize. Okay. So we are going to say, let's put a to do here. And we can say initialize ATM. Initialize ATM altogether. Can I say that? So we are going to initialize the ATM state based on whatever state we are going to get. Okay, we'll come back to it. But I believe this ATM class is making sense to everyone. Can I say that? Is this point making sense? That what we are doing with the ATM class, that you initialize a new ATM instance, right? You pass the ATM ID, you pass the DB repo so that you can access the DB layer from the service layer, and then you fetch the ATM details from the server. And then we are going to allocate a state. Okay, cool. But before I allocate a state, now what are the functionalities the ATM is going to provide? What do you think? The functionalities that ATM should technically provide should be something like this. ATM should allow insertion of a card. Right. ATM should allow insertion of a card. ATM should allow ejection of a card. Okay. What else? An ATM should allow enter pin, Okay. What else? An ATM should allow request cache and an ATM should allow, let's say, cancel transaction and so on. Now just think about it. Should we implement the logic of insert card, eject card, enter pin, request cache inside the ATM class? Do you think we should implement all of these logics inside the ATM class? What do you guys think? Should we implement the logic of insert card, eject card, enter pin, everything inside the ATM class? No. That's what we just discussed previously. In the approach one, that was the problem that we had, that we were implementing everything inside the ATM class. Now, the problem is that what state your ATM is in will decide what will happen on an action. If your ATM is in a ready state and you try to do enter pin, this should technically not work, right? So what you're going to do? Are you going to say something like, if this dot state is equals to ready, this dot state is equals to ready, then do something else if this dot state is equals to cash withdrawal, then do something else if this dot state is equals to get card details, something like this maybe. Then do something and so on. Do you think we are going to implement the functions like this? No. Why? This will violate open close principle. Because insert card, eject card, enter pin, request cache, cancel transaction, all of these are actions. All of these are actions. What will happen if these actions are executed on a particular state of an ATM is not the responsibility of the ATM class. Can I say that? Listen to me again very carefully. Insert card, eject card, enter pin, request cache, all of these are actions. If these actions are done on different states, then something else is going to happen. For example, if you put insert card in the ready state, then the transaction will start. But if you do eject card in a ready state, that has no sense altogether. You cannot do eject card on a ready state. So if what will happen on the action is the property of the state, why do you want to put it in the ATM class? We should not put it in the ATM class. That means what we will do is we will just say this dot state dot insert card. That's it. That whatever is the state, we will initialize the state object. Here we will initialize the state object, right? So whatever is the state of type ATM state, it has an insert card function. You can see it has an insert card function. So whatever is the state, we'll call the insert card function. Whatever is the state, we'll call the eject card function. Whatever is the state, we'll call the enter pin function, and so on. Can you see? So we have delegated the responsibility of each action to individual state. That, hey state, you know what you have to do on a particular action. So let's make this implementation inside you only. Okay. So this is just simple delegation of task. Dot request cache. Okay. Let's say state has a request cache method or not. Yep. We have a request cache method. And then this dot state dot cancel transaction. And so on. Okay. So that's how your ATM class is going to look like. That's how your ATM class is going to look like. Okay. Now, how your states are going to look like. Let's start talking about that. Okay. So we'll say class init state. The init state is going to implement ATM state. Can I say that? The init state is going to implement the ATM state altogether. Yes or no? Right? Now, inside the state, we are going to keep a ATM instance. ATM instance. And in the constructor, we are going to initialize the ATM as well as this dot ATM is equals to ATM. Can I say that? Now, why we are keeping the ATM state here? Why we are keeping the ATM state here? Because just think about it. Let's say you are in the init state. The ATM is inside a ready state, or let's call it as a ready state. Let's call it a ready state. So let's say your ATM is in a ready state. In the ready state, if you do eject card, will something happen? No, nothing will happen on an eject card. But in a ready state, if let's say you do insert card, you can see there is an insert card method. Let's implement the insert card here. You can see insert card method is there. So in a ready state, if you do insert card, what will happen? The card will be taken. The card will be taken properly. Can I say that? And your ATM will be moved to the card reading state. Just think about it. If you are in a ready state and you do an action of insert card action, you did, then what will happen? You will move to a card reading state. Can I say that? Whereas if you do a eject card action, then you will go this, then this will be not allowed. Okay, right? So that means inside the ready state there will be some methods like insert card which will work properly. We can say console.log card inserted. Now starting to read details. Okay, and then what you need to do is you need to move the ATM from ready state to card reading state. Can I say that? Move the ATM, or I would say change the state of ATM. Change the state of the ATM. If you want to change the state of the ATM inside the insert card method of ready state, you need to have access to the ATM instance altogether. Can I say that? Drop a quick yes or no in the chat. Can I say that? If you want to move your ATM from the ready state to a new state inside a function of the ready state class, you need to have access to the ATM instance. That's why we have kept the ATM instance altogether, right? Now the ATM class should implement a very interesting method called as set state. Okay, we should have a set state method. This set state method will take a state of type ATM state. It's of type void, return type void, and this will update the state of the ATM. This will update the state of the ATM. So what we are going to do is we are going to call the set state function from here. This dot ATM dot set state. Are you guys able to get this point? That when you insert the card in the ready state, we want to change the state of the ATM to card reading state. We want to change the ATM state to card reading state. Make sense? So we need to call the ATM dot set state function from here. We need to call the ATM dot set state function from here. So let's see how this set state function in the ATM should look like. We will say this dot state is equals to state. So allocate the state object, and we will say this dot db repo dot update ATM status. Okay, we'll pass this dot id comma this dot state dot get state name. Okay, so every state will be having a function of get state name, right? So let's write a function get state name, and from here we can return ready. Okay, something like this. So we'll pass the state name to the database. Can I say that? Yes or no? We'll pass the state name to the database. Yes or no, guys? Yes or no, guys? And every state, if you see, right, has a enter state method. This will help us to enter the state. So the moment we update the state here, we are going to call this dot state dot enter state. We are going to call this dot state dot enter state. So you can see now from here we are going to pass this dot ATM dot set state. What is the state that we want to have? Let's say we want to have a new card reading state. We want to have a new card reading state. Are you guys able to get this point? So see, during insert card, We are going to make the ATM go from ready to the card reading state. Are you guys able to get this point? Aditya says, I'm using a pub sub of IO Redis in a client project. I'm facing disconnection issue after 10 minutes. I need to restart my server after some time. Please help me. You need to check how many active connections your IO like Redis server is maintaining. Is there any particular type of a load that is coming on the server? You need to check all of these things. Is this point making sense, guys? Is this point making sense? That now the whole delegation of what should be technically done during a state when an action happens is existing inside the state. Now just think about it. For the eject card, we will say console.log eject card not supported in ready state. How cool is that? Right? Let's put it here. Here we go. You can see eject card is not supported in the ready state. How cool is that? And so on. You can have more functions like this, right? So let's say enter pin, request cache, all of these are not going to be supported. So I'll just copy this. Oh, sorry, copy this, and let's say I'll paste them here. Enter pin. Technically, enter pin is also not going to be supported. Console.log enter pin not supported in ready state. Then console.log request cache not supported in ready state. Okay. And so on. Similarly, copy, paste. Cancel transaction not supported in the ready state. Make sense, guys? Now, in a similar way, I can implement the card reading state class. Card reading state. It's going to implement ATM state. It's going to implement ATM state altogether. Can I say that? And this is also going to have all of these functions. So I'll just copy this from here, paste it here. It will also have an ATM instance. State name will be card reading state. Okay. Now, will insert card work for the card reading state? Will the insert card work for the card reading state? No. So we should say card already inserted. Console.log card already inserted. Okay. Now, can eject card work on the card reading state? Just think about it. If somebody clicks a cancel transaction or somebody clicks a eject. So let's say in the ATM machine, there are two buttons, eject and cancel. Eject and cancel. In both of these situations, what can happen is, you can revert your state back to the ready state. Can I say that? Okay. Or just think about it like this. What is eject card? Let's say you swiped your card back. If you swiped your card back, then we can say console.log card ejected. And this dot ATM dot set state as new ready state. Just think about it. If you ejected your card when the card was being read, then the transaction will just go off and the ATM will come back to the normal position. Can I say that? But if let's say you clicked on the cancel button to cancel the transaction, so we can say console.log transaction cancelled, and we can say this dot ATM dot set state, and we are going to go to a new cancel state. So there will be a cancel state altogether. Can I say that? How many of you guys are able to get this point? Say a yes or no in the chat. Okay. Similarly, enter pin will also work, right? When you are going to enter the pin, then the card details are being read. So enter pin will also work, right? Console.log, user entered a pin, entered the pin, user entered the pin. Now just think about it. If the pin is correct, then we will go to the cache withdrawal state. If the pin is incorrect, we will go back to the init state. Okay. So let's say the pin method also expects a pin. The pin method also expects a pin. Pin. And let's change in the interface as well. Pin. Okay. Pin. Okay. So we are going to check somehow if, let's say, is pin correct. So let's say there is some database method is pin correct. Okay. That is going to check for our, let's say this dot ATM dot is pin correct. So let's say inside the ATM we have some pin checker method. If the pin is correct, we are going to move our ATM, this dot ATM dot set state to new cache withdrawal state. To cache withdrawal state. Okay, to cache withdrawal state. Else, we are going to move to ready state. Let's say you gave a wrong pin, we are going to go back to the ready state. That okay, we are in the ready state, and so on. Okay. Yes, Gomsi Sharma is actually saying the right thing. Guys, do you feel there is a problem now with our state classes? Is there any problem with our state classes? There is indeed a problem. Always, your classes should not depend on other concrete classes. Instead, they should depend on some polymorphic type or something else. Can you see? Ready state is having a very tight coupling here. And also something like this new ready state here, new cache withdrawal state here, and so on. Now just think about it. What is the problem? Let's say currently the ready state constructor doesn't take any argument. It's okay. But let's say after some time, ready state constructor starts taking a couple of arguments. So in all of the other state classes where you have used this new ready state, you have to make changes everywhere. And that is the problem of just exploding your new calls here and there. What does help us in this case? A factory. A factory helps us in this case, right? Inside a factory, you can make sure all of your new instances are being created at one place. So ideally what you should do is we should have a class ATM state factory. ATM state factory. Can I say that? Inside this ATM state factory, there will be a public static create state function. Create state function. Okay. It's going to take, let's say, an ATM instance and a state instance. Okay. Let's say state name, which is of type string. Okay. And what it is going to return? It is going to return an ATM state. It's going to return an ATM state. And now you can say if state name is equals to ready, we are going to return new ready state and we'll pass the ATM instance in the ready state. Else if the state name is equals to, let's say, card reading state, then we are going to return a new card reading state and we'll pass the ATM instance. If you remember, in every state class, the constructor takes the ATM instance, right? So here also we will give the ATM instance and so on and so on. In the similar way, you are going to implement the factory for other, I would say, states. And now what you can do is, instead of saying new card reading state here, I'll say ATM factory dot create state. I'll pass the ATM instance and I'll pass the state name. That is card reading state. Okay, so I'll pass the state name. In a similar way, here, instead of calling new ready state, we are going to call, let's say, ready like this. Okay, here also we are going to call ready like this. Here also we are going to call cash withdrawal. Cash withdrawal. Okay, cash withdrawal. Here we are going to call cancel. Here we are going to call cancel, and so on. You can see in this way you have not put multiple new statement at multiple places, and even if the constructor call changes for any particular state, you don't have to make those changes everywhere. You will just come to your ATM state factory and make the changes. And this implementation where every state, now this is what is called as state design pattern. In this state design pattern, what's the main core logic? The main core logic is that your system is in a state. When a function is called on that state, it can move to any other state. So which state it is going to be moved to? Like from ready state, if I call insert card, it will be moved to card reading state. Which state it will move to? This logic should be segregated in a separate state class. This logic should not reside inside the ATM class. Otherwise, for every function, there will be a lot of if else check, that if state is ready, then do this. Else if the state is cash withdrawal, do this. Else if the state is cancelled, do this, and so on. This will violate the open close principle. But if we have separate dedicated state classes inside which each class maintains that what should happen on a particular operation or a particular function on that state, and what is the next state we are going to move to, then this is called as a state design pattern. And this factory is the factory design pattern where we are going to segregate the creation of every single object in a separate class altogether. How many of you guys are able to get this point? And you can see in a similar way, you can implement more states like cancel state, dispense cash state, eject card state, and so on. Are you guys able to get this point? Say yes or no in the chat. That how the state design pattern is technically working. Time for questions, guys. Time for questions. Gaurav says factory class kaise? So Gaurav, where do you use factory pattern? Wherever you have to handle the object creation logic. Object creation logic should go inside its own factory, right? So that's why ATM state object creation logic should go to a ATM factory. More questions, guys. I would like to answer a couple of more questions. It's just like if you see, let me show you. So I have a algo code evaluator service, something like this. Okay, if I show you, then can you see there is a container factory? Can you see there is a container factory? What is the use case of this container factory? This container factory handles the creation of a Docker container based on the image name and the command to be executed on it, so that we don't have to separately put it at multiple places. Tarun, like there is a front end one in which we are going to talk about a couple of front end system design. You can check out the website for that. Make sense, everyone? Also, you can see if your ATM has a lot of properties, then do you think creating an ATM object using a simple constructor like this should help? No. So to create an ATM instance, you can also use a builder. So you can create an ATM builder using the builder pattern and modify this ATM. But to be very honest, in a 1 hour or 50 minutes interview, that won't be probably expected, but you can still mention that if our ATM has a lot of more information to take, then instead of writing a normal constructor call, we can take it as a builder pattern altogether. Getting my point, guys? Why did we not implemented interface in our lead code project? गिरिवर्धन लास्ट कौन सी क्लास अटेंड करी है लीड कोड वाले प्रोजेक्ट की? अगर तुम यहाँ पे देखोगे, लेट मी शो यू. So if I come up here, we had this code executor strategy, which was an interface. Girivardhan. So there is this code executor strategy, which is an interface, which is implemented by each and every single strategy. For example, if you go, Python executor implements code strategy. So this was the implementation of a strategy pattern. So in the lead code project, in the backend batch, in the lead code project, every service is made using different technologies to understand multiple things. So the evaluator service is written in TypeScript. There we have implemented a couple of interfaces wherever required. Please first watch it and then come back. Any more questions, guys? Any more questions? That how this ATM machine is working and how from this simple ATM class we have modified our solution to make it more extendable and more reusable. No questions? How to come up with this approach? Now, Samir Bisht, like that's why you have to pre-prepare yourself, right? That's why you learn design patterns manually, so that when a question is given to you in interview, then you can actually decide what design pattern will be actually implemented here. Now, just think about it. Think about an elevator. Okay, a good homework problem for you guys would be to design an elevator. An elevator also has multiple states. That let's say your elevator might be on a halted state, then somebody presses a button, and then elevator will move to a moving state. So some function happened, and your elevator will go from one state to another. So that kind of a problem can also come in the state design pattern kind of a situation. Apart from that, the moment I realized that my new statements are roaming here and there, that was an immediate trigger to implement a factory altogether. Then the moment we realize that our constructor call is becoming heavy, that's a direct, I would say, call to have a builder pattern, considering we might have to do some validations here as well, and so on. So generally there are two types of system design interviews. There is one LLD and one is HLD. In HLD, you are expected to talk about the intricacies of the overall system architecture. In LLD, you are expected to talk about the class design. But always keep this thing in mind. These interviews are 45-minute interviews or 50-minute interviews. So thus you are responsible to keep the scope of your implementation within these 45 to 50 minutes. How to handle different type of card link. Card can be different type, credit card, debit card, and insert card. So now just think about it. Whenever your ATM is going to start, what you can do is the moment you initialize a new ATM instance so that a new transaction can work, you can keep a card type. Okay. And then when each and every state of yours is applying an action, you have the access to the ATM instance. Now you can check this .atm card type is, let's say, credit card, then you can do something else or you can do something else. First thing. Second thing, one more thing that you can do is you can have a card type interface. And then based on that interface, you can have a different implementation for every card type. Are you able to get this point? So this is how you have to think about it. Cool. If there's no more questions, let's wrap today's session here, guys. We're going to meet soon in the next set of sessions where we will talk about a few more interesting problems on maybe some backend engineering problems or some LLD problems.